Hello humans. Several people did not do the lab activity today, and it's really important because this is Solution Lab 1 and the vocabulary is all linked to what you worked on in class previously. We're going to do our best to use as many of these words as possible many times during this activity. We're going to use several pure substances: calcium chloride, magnesium sulfate, ammonium nitrate, that one's ammonium nitrate, and sodium carbonate, not sodium bicarbonate, which you might have in your kitchen cabinet. This is, you might have this in your laundry room though. We're going to use those four pure substances and another pure substance that you're very familiar with today. We're going to follow some procedural steps and measure some solvents. Actually, we're going to measure one solvent. All of these are water, just pure water. Well, as pure of water as we can get out of the tap. We noticed a couple things about some temperature changes. Here are what the compounds that we're going to be using look like. Let me get you some close-ups of these so that you can focus. Something interesting about the calcium chloride, you may notice that there's some shininess on those shapes. Those are not really spheres, they're just small pieces. There's the magnesium sulfate. It's crystalline in structure. We've used this previously. Of course, water. Ammonium nitrate. Notice we've got this label compound for each one of these. One of our vocabulary words is compound. So this is not an element. This is a chemically bonded nitrogen, hydrogen, and that's an ion, and an ion of nitrogen and oxygen. The ammonium nitrate has a little bit more color to it because I think it's got some impurities that we don't know about. We're going to assume that it is close enough to pure for our 8th grade purposes. Sodium carbonate. This one is also crystalline in structure. I believe this has been ground so that it will be small pieces that will dissolve more quickly. We're going to notice that some of these dissolve almost instantly and some of them persist for a short time. These have already been scooped out. These are the same. You'll want to make some notes. And you can't see the whole chemical formula or molecular formula for these, but you can make some assumptions. So this is the one that begins with sodium. This one begins with the ammonia, magnesium, and calcium. And you can see that the substances look the same inside our test tubes. We're going to go ahead and just right off the bat add water. Your lab activity says for you to measure 4 milliliters each. These happen to be 5. So 5 milliliters. And the instructions say to agitate the test tube. So we're just going to give a little shake just to make the mixing occur. We don't want to just stratify. And you can tell that some of the solute, that's the solid material at the bottom, is becoming dissolved in the liquid. This does not happen instantaneously. It does happen more quickly when the solid material is more finely divided. In a couple of these we noticed that there was a temperature change. So both of these thermometers are beginning at approximately, get a little bit below 20 degrees Celsius. So we're going to put that in with the calcium carbonate and and the ammonium nitrate. Like I said, both of those began a little bit below 20 degrees, and what you can notice, even if you can't read the numbers, what you can notice is calcium chloride is releasing quite a bit of heat. So the temperature is up over 40 degrees Celsius, and the ammonium nitrate is absorbing heat. So this one has gone down to almost 10. Let's see if that's, let's give that a little mix. This is easier to see in person. Okay, so we've gotten cooler on one and warmer on the other one. Now, this was deliberately chosen ahead of time because we're talking about the difference between causing a mixture versus perhaps a chemical reaction. One good clue that a chemical reaction happens is a change in the energy level. Unfortunately, this is a red herring. If you've learned that from language arts class, a red herring is a misleading clue. Remember, chemical reactions only occur if a new substance is formed. So even though there's an energy change, there's not a new substance forming, they're just mixing. I'm going to get these out of here so that they don't fall on the table. But that is something that we would want to notice during lab. Let's take a look at the solutions. So this is the sodium carbonate in water. Some of the solute remains at the bottom, undissolved. And since we have a partially dissolved solute, we have to call this heterogeneous because we've still got the solid substance at the bottom and we've got the water that has dissolved some into a solution above. So this, in this test tube right now, is considered heterogeneous. Ammonium nitrate, same thing is happening. Some of the solute is dissolving, and you can see, well, I can see in person that there's a swirling of higher concentrations and lower concentrations as the two materials are mixing and the solute is dissolving. This is the magnesium sulfate. It had smaller crystals. It appears that more of this material is dissolved. Sometimes dissolves more quickly because of the size of the particles being dissolved. Sometimes it dissolves more quickly because of the solubility of the solute. So calcium chloride. And this one is a little foggier than the others. That's okay. All right, so at this point, in the instructions, it says to draw the test tube and label the tube solvent, solute, and solution, and make any other observations that you might have. Here is one example. Now, we were doing this for each test tube, not just the one. So let's see what happened. Let's see, we're talking about, okay, the solvent for all of them is water. There's always some air in the top of the test tube. Okay, this one is calcium chloride, so let's go ahead and get that in front of us. So in the calcium chloride mixed with water, the calcium chloride is the molecular formula for calcium chloride. So molecule is one of our new vocabulary words. The molecule of calcium chloride represents a pure substance. Since this is a mixture inside the test tube, we no longer have just a pure substance. Some of the solute remained undissolved. So at the bottom of this test tube, we can see that there remains some solid solute. It's getting dissolved, but it's not yet there. The solute is more dense. Now, that's the last lesson. It's more dense than the solvent or the solution, and we know that because it went to the bottom. I'm going to set this back up here. All right. Some of the solute dissolved in the solvent to form a solution. So the solution is a combination, a mixture of calcium chloride in water. Now, since we still have the liquid here and the solid here, this is a heterogeneous mixture. But if we wanted to separate the liquid from the solid, we can decant. Decanting is a way to collect the homogeneous solution, just the liquid part, that's everything's dissolved, from the heterogeneous mixture in the test tube. So decanting, and this is going to be difficult for me to demonstrate. I'm going to use a graduated cylinder, although we used a test tube in class. If I want to collect just the solution, not the heterogeneous mixture, but just the homogeneous mixture, I can simply pour the liquid part and the solid part, the undissolved portion, will remain in the bottom of the test tube. And so at this point in this container, this is now a homogeneous mixture. Everything is distributed the same. There's no chunks of solid at the bottom. I know it's a little bit foggy, but even if we looked under a microscope, every drop would look the same. So if every drop looks the same, that's not heterogeneous, then that is homogeneous. Homo means everything is the same. In a hetero, this is heterogeneous because it's not all the same. We can see that there are two different things, at least two different things in this test tube. All right, we've already discussed that mixing is not a chemical reaction. However, we have decanted, prior to the video, for convenience sake, we've decanted some of the liquid, some of the homogeneous solution of sodium carbonate. So this is just a clear liquid. You cannot look at this. Let's see if we can get a better picture. You can't look at that and tell that there's more than one thing in there. It just looks like water. And we also have decanted some of the magnesium sulfate. Once again, there's no solid particle hanging around in there. We've just got a solution. There is no way to tell in this current state that there's more than one thing in there. But we know there's magnesium sulfate with water mixed, dissolved, makes a solution, and sodium carbonate that's mixed and dissolved and formed a solution. Neither one of these is the result of a chemical reaction because a new substance was not formed, just two things were mixed together. Now, just as a little bit of fun, one of the children said, "Hey, can we mix all this stuff?" And I said, "You can't mix it all, but you can mix some of the solution from the magnesium sulfate and the sodium carbonate together." So let's see what happens when we add the solution of magnesium sulfate to the solution of sodium carbonate. And I don't think we're going to see this very well right here. How are we going to do this? All right. Whoops. Keep your eye on the solution as we mix these two solutions. Now, another clue, besides the energy change, which we decided was not a chemical reaction indicator, what we notice here, two things. We've got a color change, plus we have a new material inside of our test tube that is not sodium carbonate or magnesium sulfate, but it becomes a new substance. And I got to ask a question here, and this is the tough part. Is this new white substance soluble in water? How could we test to see if this was soluble in water? I think we should try to dump some in this cup of water. So if we dump this in the water, and we got plenty of water in here, if it's soluble, then we would expect this white substance to dissolve. Give this a swirl. In fact, it doesn't dissolve. It does mix around, but this is forming a heterogeneous mixture, not a solution. If we let this sit still for a while, those solid particles will settle to the bottom because they are more dense than the liquid. but we have evidence of a chemical reaction in this case, and this is not an example of dissolving, it's an example of a new substance being formed. So whenever a new substance is formed, that's a chemical reaction. But mixing and dissolving is not evidence of a chemical reaction. If you missed the lab activity in class, or if you want to just be thorough, you need to go back through your notes and look at your drawings and make sure that you have labels such as these and that you understand what they mean. The solute is more dense than the solvent in the solution. If you don't know what that means, I want you to write down a question so that you can ask an intelligent question in class and we can answer it clearly.